Hello class, welcome to our lesson for today in section 2.4. This is the last section of chapter 2, and this deals with applications of solving right triangles. Today we're going to focus on some general questions, but one thing that you want to make sure of is wherever you're at, make sure you have your textbook around. We're going to be looking at a few things out of that probably at the end of this lesson and the next one. So you want to make sure that you have that available to you in order to make sure that you understand what the questions are asking you to find. Okay, most of the questions that you're going to deal with in this lesson will deal with just a regular right triangle. Typically they're denoted A, B, and C. What's important here is that angle A is always across from side length A. Okay, so angle A right here, side length A right here. And then typically angle C is always the right angle. So right angle here and side length C is the hypotenuse. That correlates to the Pythagorean theorem. And then this would be angle B and side length B. Not every question is A, B, and C, but most in the trig books are that way when you start solving them. So just keep that in mind that A, B, and C is always the hypotenuse typically and the right angle. So if I want to solve this triangle, first off, the angle should be easy because you know this is 39. These two angles have to be complementary because they have to add to 90 degrees. So that should be easy to find. It's the side lengths that become a problem. Now I'm going to solve everything from angle 39. You could solve the angle or the answer from angle 51 if you wanted. Okay, but I'm going to choose to solve from angle 39. So from 39, what you'll see is I have sine of 39 equals 6 over c. The reason for that is from 39, opposite is 6, and the hypotenuse is c. From there, I'm just going to basically cross multiply or multiply c to the other side, get c by itself by dividing by sine of 39. Make sure you check your answers and see if you can get to that point that c is 9.53. So you want to make sure that you can do that in those questions. Then to solve for side length A, you have a few options. You could do the Pythagorean theorem. Once you know two of the three side lengths, you could do Pythagorean theorem to find the third. One thing I've noticed when students do that is they round these answers too far and they end up being off by a tenth or a hundredth. So make sure you're careful on that as you're looking at those scenarios. The other option is you could use tangent. So tangent of 39 would be 6 over A. So from 39, opposite over adjacent. And then you just do the same idea. Make sure it makes sense here that A is smaller than C because of the right angle being the corresponding to the longest side, which is the hypotenuse. There's some information in section 2.4 dealing with significant figures. To be honest, there's not a whole lot about sig figs in your textbook. Most questions are just going to tell you to round to the nearest hundredth or nearest tenth or nearest minute or 10 minutes, like what we had in the last section. But the information is there in case you need it. There's a few questions that may ask you about sig figs, so just make sure that you're looking at those and understanding what it's talking about. Okay, the difference of this question is that they're not drawing a picture for you, but they are telling you that C is the 90 degrees. You should typically assume C is always the 90 degree angle in these questions. For many students, what is most helpful is you just draw a triangle out. Okay, my triangles always look the same. A here, angle B, and then C in the corner. So side length C is across from angle C, and that's 29.7. Angle B is 46, and then from there the question is the same as the last one. Okay, in terms of the setup, finding the third angle should be easy. Subtract from 90. And now look from here, I used 46. So sine of 46 would be the opposite, which is B divided by 29.7. Multiply the 29.7 to the other side, and then you get your answer for B. That's actually easier than the one we did before because you don't have to worry about this division piece at the end. I can find A with Pythagorean theorem if I want. I'm showing you all the trig pieces because they'll be exact answers or at least closer to what you're looking for every time. So from 46, that would be adjacent over hypotenuse. So that would be adjacent over hypotenuse's cosine. And then you solve for side length A. Notice here that side length B is larger than side length A, which makes sense because angle B is larger than angle A. The next question, same setup, just set up your right triangle, but this one doesn't give you any angles. And typically these questions are more challenging for students. So if you're given two side lengths, that's when it becomes a little bit more work. To solve for the third missing side length, just do Pythagorean theorem. A squared plus B squared equals C squared, and then work backwards to find A. If you have questions on that, let me know, but the answer should be around 608.81. Then I decided I was going to solve for side length A, or excuse me, angle A, and I'm going to use the two given pieces of information as much as possible. So you'll notice here 219 and 647 are given to me. Because this one's rounded, this side length A, I don't want to use that if I can avoid to. So from A, 219 is adjacent, and then 647 is the hypotenuse. So I just set it up, cosine of A equals 219 over 647. And then to find an angle, you always do the inverse. Okay, so you do cosine inverse, find the angle, round to whatever it tells you, or nearest minute, 10 minutes using DMS, and then find angle B by doing 90 minus it. So every question is going to need trig at some point to find the answer, and then you can use other methods to hopefully find other pieces. Okay, remember, when you find an angle, you should be doing the inverse trig function. Just some review questions. Find the answers from 0 to 360. You'll notice here that you do sine inverse because here's sine theta, so do the inverse of the decimal. I'll get 47.86. That also corresponds to the reference angle, and sine is positive in quadrants 1 and 2, so I do 180 minus that, and here's 132.14. Now, the only thing I didn't do on this question that you need to make sure of, okay, this could happen to you on a test. This says round to the nearest 10 minutes, so you have to write it in degrees minutes. Notice my answers are in degrees with a decimal, so you should be able to change that just by doing the DMS feature on whatever calculator you're using. So make sure you look at that as you're looking at your homework questions and be prepared for that on the assessment to not miss points because of something like that. Okay, what I want to look at for the rest of kind of today, along with your homework, is questions like these in your textbook. They correlate to solving triangles, so make sure you work on that a little bit to understand what's happening. The answers to these questions are in the notes and in the PDFs. You can also, obviously, if they're odd questions, you can find the answers in the back of the book. The key thing for this assessment is time. Okay, so you got to make sure that you're quick in terms of setting these things up. So you want to make sure you practice these so you have a good strategy and it's quicker for you and you're not having to look it up every time. Because otherwise, I think you might run out of time on your test. So keep those things in mind, try out some of those questions, and if you have any issues, let me know. Also, make sure you read directions. Remember, for example, like this one, round to the nearest 10 minutes. That's going to be something that's helpful for you as you're looking at those questions. Have a good day, everybody.